This is going to be the question I'm going to pose in this talk. And I want to dedicate this talk to Spell, who was with us and organized Grazer Linuxtage for a very long time. It's been a great pleasure, and we miss you. I myself, I'm Typolo, and I do have something like a life goal. I want to provide you tools for digital typesetting. I have a Mastodon account, typolo@typo.social, and I also have a GitHub account where some of these developments are visible. And in this talk, I'm going to ask, first of all, what is even digital typesetting? I want to provide some definitions, some requirements, some use cases for digital typesetting. Then I have some getting started with section. So you know the tools, how to get started, how to make the very first step. And finally, I will make a summary and try to point out the different advantages and disadvantages of the various software packages. Are we digital typesetting yet? Digital typesetting is the art of setting type by digital means. So we do have this domain of manual typesetting, where you have letters made of lead or wood, and you just arrange them one next to another, apply some paint, then put the paper on top in order to print a document. Oh, a document, right. So they have various complexity. So if you look at these 3 pages, you can see a bunch of different requirements. On the left side, you can see just some text that needs to be arranged one letter next to the other. You do have some headings in between, but in general, it's text. On the very right side, you can see that we also have something like a diagram in there. A diagram also needs to be replaced maybe side by side, and it gets a little bit more complex and so on. And some pages are very special. In the middle, you can see a title page where we do have an image and then some title for this document, and you want to point out the affiliation, the various authors, and so on. So if we want to create a document, where do we get started? In general, you have a page. Now you have something like a canvas where you can draw. There is a certain area where you can actually put your main text there. And now you just start at the top left and place the first letter there. Then the next one, and the next word, and this goes on until you run into a problem. You run out of space here. So you need some kind of strategy to continue on this canvas, on this page. What you need to find out is line breaking opportunities. In general, I'm just looking here at the space in between words. These are line breaking opportunities. Why? Because in general, there is something like a technical report by the Unicode Consortium, number 14, which is titled Unicode Line Breaking Algorithm. It just points out which are good sequences of characters where you have line breaking opportunities. Later on, you can decide which one you're going to take. In my case, I take 3 words, this comma, and then I introduce a line break. What we did here is something called the naive algorithm. Naive because what we just do is we fill up the first line, and before it exceeds, we just make a line break and continue in the next line. There are different strategies. Most importantly, there is a paper called Breaking Paragraphs into Lines from 1981, which is a dynamic programming algorithm by Don Knuth and Michael Plass. And it considers the entire paragraph. And it just wants to have really beautifully aligned text. So it's not about exceeding one line and then continuing, but considering the entire paragraph. All right. 1981. Is this even something modern? Yes, it is. We also deal with that today. So this links to a blog post by the WebKit developers. And text wrap is a CSS property that was just recently introduced. Firefox doesn't support it. They just, browser by browser, introduces this property, text wrap pretty, which allows the browser to decide, okay, I do take more time to generate a better layout and find better line breaking opportunities, avoid widows and orphans, and so on and so on. So this is something also implemented today in all kinds of settings. In this case, on the second line, I do have this scenario. I do have 2 line breaking opportunities here, but maybe a third one. What we can do is we introduce a hyphen and continue on the next line. This process is called hyphenation. It doesn't exist for every script. So what I do here is I take 4 letters, introduce a hyphen, and continue with the remaining text on the next line. If you think about, for example, Polish, in standard Polish orthography, it's a different convention. You don't introduce a hyphen and then continue on the next line, but you introduce a hyphen, start on the next line, introduce another hyphen, and then continue. It's a different convention. In order to find the best spots where to hyphenate a word, we also do have some algorithms. In general, there is a PhD thesis by Young who wrote down an algorithm given some pattern file. So this is something that needs to be found out for a language. A pattern file, we can figure out where to hyphenate a word. All right, with this strategy, we can finish our paragraph. Nice. I mentioned that this is language specific, and I had to introduce this picture just because I moved to Salzburg, and you find this under the bridge in Salzburg. That here we have a lorem ipsum text. It doesn't make any sense. It looks like Latin, but it's meaningless. The point is, all of this is language specific and also depending on the writing system. For example, what I'm showing here is some text, and now the question is, where can I break here? It's not trivial to find out that, right? This is Thai text, and you do figure out some spaces. The author of this document introduced these spaces. You might be able to use them, all right? But in general, the strategy is you need to apply this at word boundaries. Can you tell me where the word boundaries are? Because these are the line breaking opportunities. You really need to apply some natural language processing to figure out where the word boundaries are. It's pretty difficult. But LibreOffice did the job for me, so it looks like these are line breaking opportunities here. All right, and now we started at the top left, but we also have this issue or this requirement of text direction. So when we are writing, it's not always the case that our primary axis is first of all going from left to right, then we have a row, and all these rows are arranged from top to bottom on the secondary axis. This is the case for some writing systems. But we also have other writing systems which just work differently. Hebrew, Arabic, Aramaic, for example, those go from right to left and then from top to bottom. That's, in my opinion, sufficiently known. And also for CJK, we have something, so Chinese, Japanese, Korean. It's convention that in traditional, more ceremonial writing, you go from top to bottom, you get a column, and these columns are arranged from right to left. There are also some surprising text directions. Boustrophéron is a writing direction where you go with the first line from left to right, and then on the next line from right to left. So this applies, for example, for Hungarian runes or the linear B writing system, Rongo Rongo, as well. Yeah. And hieroglyphic Egyptian, for example, or also Rom, these writing systems do not really have a defined writing direction. Okay. I got the feedback I need to show some images what it looks like. In my opinion, it's very difficult to figure out anything if you don't know the writing system, but all right. So LaTeX script goes from the bottom to the top and from left to right. Okay, fair enough. With Ohm, we have the situation, it doesn't have a defined direction. Okay, how does it work? You just look at a rock, you just look at the edges of the rock, and you just write on the edges of the rock along wherever the edge takes you. That's the short strategy. Okay, fair enough. And here I have a modern example of boustrophedon, where maybe you're even able to tell that this is boustrophedon, because as far as I understand, from left to right, then on the next line, right to left, and then from left to right. Why? Because it still follows the usual convention of using punctuation like we do in our Western script. So we do have the dot, and the line ends with a dot. It must not start with a dot at the beginning, right? That's not something we do in our Western script. So also here we have this, applied the same convention. So actually this line goes now from right to left. All right. And yeah, now just to mention this, yeah, you can also apply boustrophedon to Latin script, and this is what it looks like. Okay, now nice. So we do have line breaking opportunities. We figure out an algorithm to introduce and to actually decide which opportunities we take. We also have some hyphenation algorithm and so on. Nice. And in Latin script, everything is easy, right? We always use from left to right and from top to bottom. No. So consider footnotes, for example. If you introduce a footnote inside the main text, yes, your main text goes from the top to bottom in terms of the rows. But when you introduce a footnote, it actually grows from the bottom to the top. The space you need takes away some space from the main text. So you actually need to figure out algorithmically in which way you want to arrange the space. And then we have another topic. Depending on the media you want to use to have the output, you have either page layouts, what I've just been talking about. A document is made of pages, and you have these pages available. But there might also be reflowable layouts. Essentially, the idea with the World Wide Web is that the pages can grow in general to infinity vertically. So whenever you need more space, you can just add more space up to infinity compared to a page which necessarily has a certain cut. Okay, and this is in general represented by PDF and PostScript for page layouts. These are very common formats. Hopefully nobody is using PostScript anymore. All right, so PDF is really the important part, and in terms of reflowable layouts, we have the entire web stack represented by HTML5, but also formats like EPUB for your tablet, for example, reading on a tablet. And we do have some tools which are really helpful. So I want to mention HarfBus here, because what we can use here is we use HarfBus to specify a font. Now it reads the font, it figures out which glyphs are available, what do they look like, and which spacing did the typographer define inside this font, so that I apply these conventions the typographer established. And then we have some text here, And now I can ask half-bus to tell me, okay, where shall I place the individual characters? The output is given here on the right-hand side, and it just says, for example, here glyph ID 43 shall be used first, then 72, then 79. 79 occurs twice because hello world, we have two L's here, right? So that can be identified. It also tells me the grapheme cluster, so we do have cluster ID 0, then 1, then 2, and so on. Arabic script, for example, they come together. Okay, and here also we have the exit ones. When we set the character, how much forward do we need to move? Okay, so this is really helpful. This solves a lot of these complexities, but certainly not all of them. We still need to figure out where do we break lines and so on. Nice. Half-bus is used almost everywhere. That's why I wanted to mention it. I want to get back to the question. Are we digital typesetting yet? Now I explained some of the requirements and complexities we have here. Maybe we should take a different approach to the topic. Not what do we need to consider at all, but what are the goals? So maybe some of the use cases are listed here. For example, financial statements, invoices, recipe lists. I don't know what your goal is, but all these are valid use cases for digital typesetting. Especially important might be, for example, something like academic papers. Academic papers are sufficiently complex because usually you have a lot of symbolic notation, and the academics usually sit down and write some text, and afterwards they need to compress it down to 6 pages and figure out every possible space they can still use to press this long text inside these 6 pages, which are a requirement by the publisher. All right. Now I need to trim it down a little bit. I do just pose 3 criteria that apply to the software I'm going to introduce. First of all, especially due to this event, I only consider free and open source software. Second, I do want to have paged output. If the user is typing some text and I just want to put it to the World Wide Web, there are a huge number of tools out there, but what I care about is also how to get it on paged output where we actually need to figure out where to place the element. This is not required for the World Wide Web. The browser does it. And finally, I want to have plain text input. I don't consider something like LibreOffice or Apache OpenOffice because when it comes to automation, the input we want to present on the text is variable. So maybe it comes from a database and somebody very different just defines it, or it's your invoice. The numbers are certainly, you don't look at every number, you just want to generate it for 10 million users. Then this is easier if we have plain text input. It's just a technical constraint. Okay, and we have a huge nice-to-have list. Just like I mentioned, global scripts, we want to cover all the different writing systems. It should be cross-platform, easy to install, and so on. Nice-to-haves, but let's stick to the criteria. This is something the software I'm going to introduce has to satisfy, so we can limit the options here. The first one is LaTeχ. So it was introduced in 1978 as the first release. There are 2 major releases. Afterwards, it's basically just patching and bug fixing. And it's a license which basically says rename required. So either you pass the trip test that's defined, so you have exactly the same functionality as LaTeχ, or you have to rename it. You must not name it with something associated with LaTeχ. That's a very custom license, but the entire license topic was a little bit different in 1978, right? It works cross-platform. You have LaTeχ distributions on the various systems available, and it's written in web. outside this domain, nobody knows web, I suppose. But the idea is you have one document, and out of this document you can generate the source code for the compiler as well as its documentation. So you have web, you generate the source code, which was originally written in Pascal, and the documentation, which is LaTeX itself. And these days it was rewritten from Pascal to C, so actually it works in C now. As an example, hello world, \y. You have these control sequences introduced by \, per default here, and this just tells, okay, the document is finished here. All right. And then you run LaTeX, example.ltech, to generate a DVI file. PDF didn't exist back then, so it introduced its own file format called device-independent, DVI. This is what it looks like. Fair enough. It's text written down here. Per default, it uses the computer modern font. Nice. We have our document. How does it work? Yeah, so you can invoke LaTeX without a file here, and then just ask, what's this by? What's that? Show me. So show by. And what it does, it expands the macro. So this control sequence is replaced by something else. Specifically, paragraph, vertical fill, super eject, and. Okay, nice. What's that? Actually, this is a primitive, so you just need to look it up. I don't know it by heart. I think LaTeX uses something like 190 primitives. So you just need to study these 190 primitives. And then you don't need these kind of macro thingies. All right. Super eject is I think, macro on its own. So this will be, again, replaced by another string. This entire process of string replacements is pretty neat in some way, but it generates super shitty error messages, and that's a typical problem of LaTeX. Fair enough. We have this LaTeX file. All those macros expand into another string made up of text and primitives, and this is turned into a DVI file if the font data is provided. Just to introduce a different example, we have def event. This is kind of pattern matching. So if you define these macros, it actually applies some sophisticated pattern matching. We can see it here, \event, then some placeholder, organized by is really required, placeholder at placeholder dot. Okay, and if I now use it, \event, this #1 will be GLT 2025, and #2 is going to be Grazer Linuxtage, and so on. And due to its definition, since this matches, this is going to be replaced by hello, thank you for organizing. This is what it looks like in here. Okay, so that's how LaTeX works. And just as a general example, there are also some specific macros you can define to change the paper size. LaTeX led to the development of various macro packages, and also some primitives were changed. So you have a certain LaTeX ecosystem for various use cases. In general, people don't talk about LaTeX, but more something like LaTeX, which is a macro package which makes it more usable, user-friendly. And when people talk about LaTeX these days, they don't talk about LaTeX, but PDF LaTeX, because that will output PDF. And the most important engine, I think, these days is LaTeX, where you have the Lua scripting language at hand to modify the behavior of this engine. And it's also today new macro packages still emerge, and for example, opTeX by Better. All right, LaTeX. Now, speedata Publisher. Speedata Publisher exists since 2011 and was written by Patrick Gundlach. He was actually here. He gave a lightning talk about his software 2 years ago. And The software is released under the AGPL. It works cross-platform. It's written in Go. And actually, it uses a little bit in the backend the Lua LaTeX system in order to really typeset the text. The idea is you take XML input and generate a PDF. Let's look at an example. So we do have some data in XML. So I introduce an element data, and in there we have some text, hello world. Then we introduce a second file which just defines the layout. We have a clear separation of concerns here, the layout in the one file and the content in another file. And now the strategy is, okay, with record element, I can just load this data XML file, its content, and then with value, I just access the string contained in this data element. Nice. I just run speedata publisher, an executable. It actually generates a lot of different output files. It's just very convenient. In XML, it's written down what the status is, how successful it was, what are possible problems. Very neat for batch processing in general. Okay, and in the end, we have our text, hello world. And we can change this a little bit, just as another example. Here, I actually access the data element, but with add text, I take the value of that text attribute. So here, now the content is in an attribute defined in XML. So what you have here is just XPaths that allow to access these different strings that are available in the file specifying the content. And also, there exists an element to change the page layout. 4 centimeters times 3 centimeters. Nice. Next software, SILE. Now 1 year later, in 2012, SILE was introduced. It was written by Simon Cousins, and SILE is now maintaining it. And it's an MIT licensed software, and it's just that there is no Windows support. I'm not sure there is any technical argument against Windows. It's just that nobody is maintaining it, I think. It's written in Rust and uses mainly the Lua programming language to apply all those typesetting algorithms. You take a SIL file, so again, such an example, you take a SIL file and this is converted into a PDF. SIL file, okay, what's that? It's a custom markup language they introduced based on LaTeX, right? From LaTeX, you know this kind of begin-end thingies that exist. These are defined macros in LaTeX, and they also use the same system for SILE. It's just that not the entire macro expansion thingy is available. And I also want to point out, it has first-level support for Markdown, for example, as well. It's just that this is one format as an input, but also other formats are possible. Just to show this here, we can change the paper size again here as an attribute, also in this LaTeX style syntax, and no folios. Folio is an ancient word for page number, so I wanted to get rid of the page numbers for this example. And then we have typest. So we proceed 7 years later. It's now 6 years old since the first commit. Martin Haug and Laurent Media, they started this kind of project. Anna is also mentioned in the GitHub team now. They wrote a software written in Rust. It works cross-platform. It's just one executable you download and then run on your computer. They also offer a web editor where you can create your document. And that's also the way how they finance their project in some way. it turns TIP files into PDF, PNG, SVG, HTML files. The main goal is, without doubt, PDF, because that's important for academic publishing. That's what their goal is. They want to target academic publishing. And the TIP file looks something like this. You have a heading. How can you identify this as a heading? Because you have an equality symbol here at the beginning. One equality symbol means this is a heading of first level. And then you have some text, and if you wrap it in asterisks, you have a bold text content. Okay, so essentially they invented their own markup language here. But what you can do is also attach a lot of metadata and even program in there. So you have these set rules here. For the document, I define the title, keywords, and author. That's basically what the what's encoded in the PDF metadata. And then you can also define the page layout, width and height. And if you misspell it, I just swapped the characters here, you also have this pretty modern, you know it from programming languages, a very visualized error message where the problem occurred. Okay, and this is their official example from the README. So you do have, what's worth mentioning here is they also have these dollar symbols, convention from LaTeχ, right? Or sorry, TeX, where this starts some kind of math mode, and in there you write your mathematical formula. They invented their own mathematics notation, system. It's a language on its own that you need to study, and here is a more sophisticated example. Compared to TeX, you don't need that many backspaces. And here we also see some programming example, or here a little bit more about layouting and placing elements. Are we digital typesetting yet? So this was an introduction of getting started with 4 different kind of software that meet our criteria for today. And now I need to answer this question in some way. This is my table, which somehow tries to convey which kind of use case can be solved with which software particularly good. So we have TeX. For the input, you need to learn this custom language with backslashes and this kind of macro expansion and so on. I put an asterisk here because depending on which kind of engine you use, LaTeX, Lua, LaTeX, and so on, it behaves differently and different commands are available. But the output is, these days, a PDF. The math support is great. You really, it's just the most sophisticated and mature system over time. And maybe the recommended use case is if you're into linguistics and you want to write down this thing is, and you want to write down that this sentence is on purpose written wrongfully, you need to append an asterisk at the beginning. This is very domain specific, something very domain specific you do, and you have a huge variety of C10 packages available that you can use to typeset this for a particular domain. That's the advantage of TeX, and I recommend it for that. Then we have speedata publisher. The input is XML, great. XML is really easy to convey, easy to understand, nice. The output is PDF, and math support is not available, just like footnotes, sadly. It works great for catalogs or brochures. These are typical media where you don't need math formulas in there. So this works for this use case. Then also SILE. It has a custom language, but it's really adjustable. You have the Lua programming language at hand, and whether you read Markdown or this custom language, it doesn't matter. You can write your own parser as well. If you're a programmer, this is just great. The output is PDF, and the math support is somewhat rudimentary. It's just that the community is just very small, and there are not that many use cases for math, so not very mature. It's great for self-published books. If you write a novel, then you usually don't have something, a lot of mathematics in there and so on. So this works great. And you can really apply a lot of semantic from OpenType, the font standard. So for these use cases, it's really nice. And typest has as an input a custom language. You need to study it. It's a programming language and markup language. And the output is PDF right now, and they are working hard to get the HTML output also working. And the math support is pretty good. It specifically targets academic papers, which I mentioned has a lot of mathematical symbols in there. So this is also the recommended use case. So this is my summary for the software at hand. This question I posed, are we digital typesetting, is just a running gag from the Rust community. Are we GUI yet? Are we web yet? Are we quantum yet? They are asking, are we ready for this domain? So I'm asking, are we ready for digital typesetting yet? I would claim, because there's always a summary, the roots are shallow and we can use a vast historic knowledge, but progress can be made and is also made. Compared to the previous years, now a lot of things are going on. We can see some progress. And I want to track this progress. I want to make it accessible to you to find out, okay, I have a certain use case. I want to do something in digital typesetting. Which software shall I pick? And with this website, I try to make this more accessible to the people. It's not anymore the case that there is only LaTeX. The website is run by a club, Verein zur Förderung von digitalem Textsatz. That we are running, and in general, if you like my work, then please sponsor me on GitHub. Also, the original idea of the club was to collect donations and then fund development of certain features in those different typesetting engines. That's pretty much the question I had today, and I tried to help you in some way understand that there is not only LaTeX, but you have different options and what are the advantages and disadvantages. Thank you very much. Okay, there is one question, and the people in the background try to figure out how to pass the microphone.
Hi, great talk, thank you. I just wanted to ask, how good is the math support yet in typest? Do you have any personal opinion to that? Could you go a bit more into detail maybe? Because currently I'm only using Lua LaTeX for that, for my academic stuff, and I'm interested in, can I do math equations, like even fancy ones? Can I do my tables and diagrams? So for an academic use case. And maybe secondly, how well do you think it's suited for making invoices?
Okay. So this question was about typest, and my answer in terms of mathematics is just that, what is mathematical notation? It's just that it's very difficult to limit the scope of this field, because essentially if you dive into algebra, into calculus, every kind of field invents their own new operators and notation. So it's not unlimited. The scope is pretty unlimited, and what is actually supported is always limited. So you have this fundamental problem. It's just that, in my opinion, it cannot directly compare to LaTeX, but they make a lot of progress. And it's currently pretty good also compared to the other software, because they specifically target academic papers. So in my opinion, for mathematics in general, the support is pretty good. Does it work for all use cases? No, certainly not, because it's unlimited. In terms of invoices, that was the second question, it works very great in general, because there are always new articles on NewsHacker right now about what was the latest hopefully I get the numbers right, about 1 million documents in 10 minutes, something like that. Was one blog article that recently appeared, and a lot of companies already generate their invoices that way. It's just from my perspective, you have different, depending on where your company is, you have a different writing system, and you need to deal with that as well. At that point in time, maybe typist doesn't help you directly with packages or the universe, but it has programming capabilities, and you can just introduce the text the way you need it on your own. Okay?
Yeah. And can
I think there was another question, so I would, since there is not that much left, you can come over later on and ask the question directly.
Yeah, just one remark to the invoices. This was my first use case getting into typest, writing invoices, and I found even a macro for doing these QR codes for Zahlen with code, so you get your billing information in there. Now to my question, what software did you use to prepare the slides?
The sad truth is, so essentially I'm pretty fond of the World Wide Web. I like it a lot, and I wanted to get the slides as a web page, so I looked into Slipshow. Yeah, doesn't work very good, and I ended up resorting to LibreOffice because here I'm much more faster in terms of slides. At work, currently I'm writing my slides with typest, if that matters.
Thank you for the talk, very interesting. One thing that I'm always interested in preparing input is how can I reuse it? How can I use it in another context with another typesetting engine, etc. How well, so with speedata, for instance, you have XML as input, which is excellent for reuse because you can rewrite it with all the XML tooling. How well does this work with typest?
Yeah. I consider it as an issue in terms of typist. You have your custom language. This is in contrast, for example, for me in terms of SILE, for example, where you have Lua at hand and you have this input language, but it just generates this abstract syntax tree, and this abstract syntax tree can result from every kind of markup language. The fundamental problem, I think, is just that every typesetting engine needs a different data model in some way. So when you want to write the entire text and all the instructions down in some way that can be passed to every typesetting engine. Yes, this only works if you limit your use cases very narrow and then you have a unified data model. This can be done, for example, for markup languages when you identify, okay, you want to have paragraphs, you want to have hyperlinks, you want to have ordered and unordered lists, and so on. Yes, you can define this and then generate this towards all kinds of data models. Sure, that works. But in general, there are a lot of frontends which try their best to do that. Also, Quarto, for example, allows you to write down the metadata and then use this as a frontend before you pass the data to the typesetting engine. But it's just fundamentally difficult until we really figure out how typesetting should work in the modern times and we have a unified data model for all the engines. We're not there yet. For me, it doesn't really work in a satisfying manner. I don't really have an answer.
Thank you.
So why is HTML and CSS and the browser not part of this list? Why doesn't it fit? And how would it compare, maybe?
Yes, thank you. I slipped in some criterion here, paged output. Now, some people are going to ask, wait, I can take a website, just press Ctrl-P for print, then this dialog appears to generate a PDF, right? The answer is yes. Indeed, you can generate a PDF this way. It's just the problem that there are certain areas in the web which are incredibly underfunded. You can listen to the Igalia chat. They discuss all these kind of progress, these topics in terms of the World Wide Web. We have underfunded areas, for example, mathematics, MathML, and also, for example, the paged CSS, so the CSS instructions for paged output. You cannot really properly define in CSS what the margin looks like for the different pages, what's a title page, and so on. This is just a standard which never really developed in a sufficient way, so it's not supported by browsers. Yes, you can take a website, print it to PDF, it's just that you cannot really customize it in any way, and therefore I don't consider it ready for paged output. That's my answer to this question. So I slipped in this criterion in order to exclude web browsers. And the same applies, for example, for graphical user interface toolkits. Also, graphical user interface toolkits have this window, and they need to decide at some point in time where they line break, for example, or hyphenate. They need to implement these algorithms. Yeah, depending on your point of view, I don't consider it directly as paged output, but yeah, fair enough.
Maybe it's a quick follow-up to the HTML question. Where do you see EPUB in that whole thing? I know it's kind of, it uses CSS, if I'm right, but the output isn't really fully reflowable like an HTML page. If I have a Kobo reader or something, I get paged output, but different paged output depending on the device. So where on that spectrum would that fall?
The thing with EPUB is essentially it's a subset of this entire HTML5 stack. You do have HTML, you have CSS, but there was this MathML core initiative that right now we have a certain limited set for mathematical notation inside web browsers. That's a huge achievement that all the browser engines finally support this. Incredible work by Igalia, great. And now the situation is that when it comes to EPUB, it's like, okay, we take HTML, sorry, I don't know their numbers by heart, but essentially back a few years and a few years there. So essentially what's in there is a limited set of instructions that you can actually use to write down documents. So usually when you have HTML output, you usually can also provide EPUB because you just need to wrap it in a certain structure, compress it in an archive file format, and then you have EPUB at hand. But yeah, it's just you don't have that much capabilities in that sense. All right, the end symbol has been shown. So thank you very much again.